Welcome back. Let's tackle another problem. And today we're looking at week 3 sum. Week 3 number 5 is 3 sum. And that's leak code number 15. Given an integer array nums, return all the triplets num_i, num_j, num_k such that I does not equal j, I does not equal k, and j does not equal k. Okay, so that means that the indices are different, not that the values are different. And nums_i, nums_j plus nums_k equals 0. Notice that the solution set must not contain duplicate triplets. So duplicate triplets. Okay, so you just can't use the same numbers, I guess, to make up the set, right? So let's look at this example 1. Nums is -1, 0, 1, 2, -1, -4. Okay, so do they use the same numbers? They do. So -1, -1, and 2, that means it's, you can use the same number twice, but you probably can't do 2, -1, -1. You can't just use the same numbers in different orders, right? -1, 0, and 1. All right, so the distinct triplets are -1, 0, 1, and -1, -1, 2. Notice that the order of the output and the order of the triplets does not matter. Okay, so example 2, there's no such triplet. Example 3, all 3 zeros is a triplet, and you're using all 3 zeros, but you're not using them in a different order. So this is similar to 2-sum, but it's more similar to a problem called 2-sum 2, because the difference here is that the numbers the approach that we're going to take would be easier if the numbers were sorted, right? So if you have, let's say you had random order numbers. You had a 1, a 6, a 1, zeros maybe, and -1, -1, and 3. Or maybe let's move this around here. Let's say you had something like this. Well, the brute force way you can do this is do the triple for loop, right? So you can start here, here, here. Go ahead and make these pointers so it's more clear. So you can start with these pointers, right? I'll make this blue. I'll make this red. I'll make this green. And maybe I'll cascade them so it's a little bit clearer. And you could do 3 for loops, right? So this for loop can go all the way to the end and figure out what it is, right? So it's going to be 3 plus -1 plus 1, which is going to be 3. And then you're going to move it all the way down. So you're going to move it all the way down to here. And by the end of it, you'll have 3 plus -1 plus -1. And that's going to be -5. Or it's going to be, sorry, it's going to be 1. And then you're just going to continue the for loops, right? So this red one moves over. You start a new iteration. Red one moves over. Start a new iteration until the red one gets all the way down. One away from the end. And then the blue one goes over. And these reset, right? And you could do a triple for loop. And that's a way to solve it. It's going to be n cubed. But let's, for a second here, let's not think about the 3-sum. Let's think about the 2-sum, right? So what would 2-sum look like? And what would 2-sum look like sorted, right? So the reason we're thinking about sorted is because, an improvement on this n cubed would be n log n. And then if we can do linear operations on the n log n, right? Because n log n would be the ceiling. And then if we did some O of n operations, that wouldn't affect our runtime, right? And we can do some of those. So let's sort these and let's see what that looks like. So let's have -3, -1, -1, 0, 0, 0, 1, 1, 6. And I'm just going to write skills here. So what do you know this now that it's sorted? Well, if we had a pointer here, and we had a pointer here, Well, now that it's sorted, we could do the same thing. We could do the nested for loop, right? And that could work. Another thing we could do is if you had 2 pointers, right? And one was on the left and one was on the right. Then when you add these two, so this one, it would be -3 plus 6, right? That's a 3. You know that the sum is guaranteed to be decreased if you moved any one of these pointers to the left, right? But you don't want to move both pointers. You can go ahead and move the 6 pointer, right? And the total will be decreased. So 6 to the 1, it's going to be -3 plus 1, and that's going to be -2. And you can move it again, and now you're at -3 plus 1. And okay, so here's something you don't want to do, right? I'm checking against the 1 again. Number 1, that's not going to add any information to me. And number 2, if these were, if these did equal 0, then I don't want the duplicate, right? So imagine I completed this, and you know, there's well, I don't want to complete it. So imagine I had maybe some type of grouping, right? Some idea that once I get to this 1, then my next iteration will move past the 1s, right? Same thing with these 0s. Once I get to the 0, if I had to iterate, my next iteration would be past the 0s, right? Same thing with these -1s. My next iteration would be past it, right? So a skill that I would need is iterating or skipping duplicates, right? Dupes. So that's a skill that I would need. So here I'm at the 1. It goes to the 0, right? And this is 3 plus 0. It's -3. Sorry. So, you know, the ordering is wrong here, because once I hit this negative, I should have increased the left side, right? I should have increased one of these numbers. So I'm going to go ahead and delete this. So here, it's -2. I move this left one, right? I move this left one, and it's -1 plus 1, and that's going to be 0. So that works. Now, which one do I move when it's 0? Possibly doesn't matter, so I'm just going to go ahead and move the left one. I move the left one, so I need to be able to skip that block, right? And then that's going to be 0 plus 1. That's going to be 1. I know that I can move this one. I moved it here. 0 plus 0 is 0. And then because it's it's a 0, I can go ahead and move the left one past the block, right? And now that left has passed right, I can stop this iteration. So that's one way I could do 2-sum. If you were given a sorted array, you could do 2-sum in linear order, right? It's pretty easy here. And there's probably another optimization you can do in that, even if the left was here, and imagine that the right was all the way down here, and there are many numbers, let's say it went up to like 1,000,000 or something. I guess one other optimization that you can do is like once the left hits a positive number, you know that there's nothing that can be added to it that's going to be 0, right? So 1 plus 1 equals 2, 1 plus 100 equals 101, 1 plus 1,000. There's nothing that can be added. So I guess you could stop here as well, right? You could exit on left at a positive number. That might be overkill, so I might not actually do that, but that's a possibility, right? So for clarity, I'm going to move everything back. So imagine you did not see all these dots, and we're going to move everything back. Okay, so that's the end state. So that's 2-sum. So imagine if this is 2-sum, right? If this is the problem of 2-sum, and we had a function, and that function was called 2-sum. Well, then we can apply this to 3-sum, right? Where if we had some other set of numbers, right? When given a single number, we can basically run toSum on the remaining, right? And as we're iterating over this number, we just continually run toSum on the remaining list, right? So wish there was a better copy and paste functionality on this clipboard, but you know, you get it. So you're here, you run toSum on the rest of it. You're here, you run toSum on the rest of it. You're here, you run toSum on the rest of it. You're here, you run toSum on the rest of it. So it's still nested. So this would be n squared, right? Basically, for each one of these, you're going to run a linear operation. For this, you're going to run a linear operation. For this, you're going to run a linear operation. So that's better than the end cube that we had here with those 3 pointers, right? And this is a way we can do it. So, you know, if they weren't sorted, you know, let's go back to our original example. Where's our this is our unsorted. So if they weren't sorted, really sorting it would be the move, right? So I don't remember if this problem has it sorted. It does not have it sorted. So it does not have it sorted. So it makes sense for us to sort it. So let's think about the code. We drew the diagram. Let's think about the code, right? So we have something like this that we're trying to mimic in code. And the way that we can think about it is we're going to have 3 pointers, right? So three pointers. We're going to have 1 pointer, and this is the gold one. And then after we create the gold one, we're going to have a left and right pointer, right? So go ahead and make that red. I'm going to make this blue. So let's think about where we want this gold one to go. We want the gold one to go all the way to here, right? So I'm going to say function solution. Solution is going to get passed in some array of numbers. And we're going to do the, I'm going to call this P1, pointer number 1. So pointer number 1 is going to go where? It's going to go for, I'm just going to say for loop here, for loop from 0 to, 2 away, right? And what's 2 away? 2 away is the length of nums and minus 2. Something like that, right? I hope that's correct. So the length of nums number 2, and then in this for loop, we're going to initialize 2 pointers, right? A left pointer, right? So P2 is the left pointer. P3 is the right pointer. And where is the left pointer? Well, the left pointer is wherever this one is. Let's say it's at index I. It's going to start at I plus 1, right? And where's the right pointer? Well, the right pointer is always going to be, here in this blue. Go ahead and make this left red. Where's the right pointer? The right pointer is right here, right, in the blue. This looks sloppy. I'm going to go ahead and make an arrow here. So what position is that? That's going to be right equals the length of nums minus 1, right? It's going to be 1 away. Okay, so go ahead and make that blue. So now we do that iteration, and the iteration is moving the left and moving the right, right? I'm going to do it while left is smaller than right. Then we're going to do some iteration, right? And the iteration is, we're probably going to do a check. So check if the sum is 0, right? We have to do some type of check. And if it is, I'm going to delete the word check there. So sum is 0. So in this case, we want to do something, right? So we have some logic. What happens when the sum is 0? we probably want to add it to some results array. So let's add it to some results array. We're going to add it to results. And then we have to do, where's that? We have to do this skipping, right? Remember this skipping? So let's say we're here at, go ahead and delete this. We're here at -1, and we're here at 1, right? So if we do find a match, because -1 plus 1 is 0, then we want to do some iteration. And what that means is we want to move this left to where it's outside of this block, right? And you know, actually, if we move the left, that means this right will definitely not sum to 0, right? Because if -1 and 1 sum to 0, right, then if we increase this by any amount, then there's no way that it sums to 0, right? Because just by, you know, like what number could we possibly move from -1 to sum by 0, right? So -1 plus 1 equals 0. If we move this in any way, right, plus 8, let's say, then that would be 7 plus 1. That would never be 0. So we can also move this past the block, right? So we move that past the block. So how do we do that? Comment here, move left position until not equal, right? And we can do that with the while loop. So while whatever's at left, right? So let's say it's 7, 7, 7, 8. Here's our left pointer, right? So we want to make the judgment onto this 7, right? Is this 7 going to pass our test, right? So while the nums at left is equal to nums left plus 1, well, we increment left, right? So then here it equals, we increment. Here it equals, we increment. Here it does not equal. So, well, here it does not equal. We want one extra little push. So I guess we can just, we can't do it from before because we can't check this direction, right? Because this would be a 6. So we want to look forward. And then I guess after we do it, we could just add another one, right? Plus equals left again. And we want to do that same thing in the other direction. So let's say this is a right pointer, and the right pointer can check this 7, right? Check if this 7 is equal. And it's going to be while num right equals nums right minus 1, then right minus equals 1, and then right minus equals 1 again, right? So we have to still do this correction. And that looks good, right? So at this point, we're at a valid state again, and then we can go back into while loop and check the sum. What if it does not match? So what if the sum is not 0, right? So let's look. Let's delete this. Okay, so we're right here. Okay, so we're right here, right? So this is some number, and this is some number here. And what if the sum is not 0? So what if the sum is more than 0, right? So it's more than 0, the sum is actually 1,000, right? So if the sum is 1,000, what do we do? Make this red so you can see it. Well, if the sum is 1,000, we know we want a smaller sum, so we move this right pointer down, right? So let's go back here. If sum is larger than 0, right? If it's like 1,000 or something, then the right goes down 1, Else, if it's the other way, then the left goes up 1, right? And I hope you can read my handwriting here. But this does the logic of this 2-sum, right? So for this particular item, the 2-sum works, right? It works until the left passes the right. Now, one thing that we haven't mentioned is, what if this gold arrow has the same number here? So we don't want the gold arrow to go from here to here if both those numbers are -1, right? We still want to have this gold arrow, pointer number 1, pass through the block, right? It has to pass through the block. How do we know that? I guess at any point, it can look to the previous position and check if that value is the same, right? So if you have a gold arrow here, or pointer number 1, and let's say this is 8, 8, 8, 8, right? You start at the 8, and you iterate 1. You look behind yourself, and you check, is this a match with this? If it is, you move. Is this a match with this? If it is, you move. If this is a match with this, if it is, you move, right? You move on to a 10, let's say. Is this matching this? It's not? Then we can do our iteration, right? So maybe in this for loop, go ahead and make this gold right here. We need some of these specific checks, right? So if match previous, then we continue, right? And you know, there's also that thing that we said, why even check a 10, right? If we check a 10, every number here will not sum to anything. That is 0, right? This could be 1,000 here. This could be an 88 here. This could be a 50. 10 plus 88 is never going to be negative. You know, it truly is, this gold pointer either has to be on a 0 or a negative number for this to work. So if the element is larger than 0, we also continue, right? Go ahead and put that in gold. And I don't know if the color matters to any of the watchers here, but imagine that the 2-sum portion is green, right? This 2-sum portion is green. This 2-sum portion is green. Then this code right here, this entire code is the green code, right? This is the 2-sum part of it. I hope I can move this up and nobody gets confused. I'm going to move this a little higher. I don't even know if anybody follows these diagrams, but this is how I would think about it, right? So let's go ahead and code this. All right. So first things first, we want to sort. And you should probably practice how to sort in your language, because it's quite easy to forget how. I don't even know if this is the right way to do it. So I'm just going to go ahead and see what comes out of here. So I have some sorted nums. Perfect. So I have -4, -1, -1, 0, 1, and 2. Perfect. Now I have sorted nums. And I'm going to just write some comments so I have some understanding of what I'm doing, right? So I have P1. This is my first pointer. Inside of P1, I have a P2. This will be my second one. Inside of P2, I'm going to have a P3. And then I'm going to have the, this is going to be a P1 loop. And then this inside of this loop is going to be the P1, P3, 2-sum, right? And that's going to be the pointers. Inside of that, check. So if sum is 0, we're going to do some logic, right? So we're going to add to results. We're going to move left until it's a new element. And then we're also going to move right into a new element. And then if sum is not 0, then it has to be either larger than 0 or smaller than 0, right? So if it's larger than 0, we're going to move right. Else, we're going to move left, right? And this is the structure of the code. This is everything that we have in this diagram, right? So everything that we have in this diagram is contained within these code comments. So let's think about how to loop, right? So we're going to loop for I, choosing I as index here, in range 0 to some number that's 2 away, right? So typically here you do range of length nums, right? This will take you from 0 to nums. I think the 0 is implicit, so you might not even need the 0. -1 will take you 1 away. -2 will take you 2 away, right? But what if there's not 3 elements in this problem? Well, results are right here. If there's not 3 elements, we're kind of in a bad spot, right? You can't do 3 sum with 2 elements. So let's just do a check here. So if the length of the nums is smaller than 3, then we're going to go ahead and return this empty results. Otherwise, we're going to sort it and do some other stuff, right? So we're going to sort it. We got our P1. Let's initialize our P2. So our left is going to be I plus 1. Our P3 is going to be right. And that's going to be the length of nums -1, right? And that's the blue right here, right? And then we do the green. So the green is our 2 sum, right? So the green is our 2 sum. We're going to say while left is, can it be equal? I don't think it can be equal. So while left is smaller than right, we're going to do some stuff, right? So what is the sum of, I'm going to call this 3. So what is the sum of all 3? The sum of all 3 is going to be nums at the pointer number 1, which is going to be I, plus the nums at pointer number 2, which is left, nums pointer number 3, which is right, right? So this is our 3 sum. Now, what happens if 3 sum is 0? Well, if 3 sum is 0, we're going to perform this 2 sum type algorithm, and otherwise, else if, I guess I don't need an else if. Some people prefer it, but it's 3 exhaustive cases, right? So if 3 sum is larger than 0, we're going to move right, and if 3 sum is smaller than 0, we're going to move left. And we can actually make this an else. I guess technically this can be an else if, right? And what does this mean? Well, this is just right going to right plus 1, and this would just be left going to, right, the advancement of right would be -1. The advancement of left would be +1. Okay. Okay, so let's look at this 3 sum. So in the 3 sum, we're going to append something to results, right? And what we're going to append is the 3 elements. So what are the 3 elements? It's going to be nums at I, nums, should it be the elements or the indices? What are we returning here? Elements or indices? We're returning elements. Okay, so nums left, and then nums right. Right, so this is going to be an array of 3 items or a list of 3 items, and that's going to be results. So we're going to move the left until we get a new element. So while the num at left, while this element, right? Let's just go back to the diagram so it's clear. Okay, right? We have all these 8s. While this is looking up ahead, and look up at 1 ahead, while num left, right? Triple equals num left plus 1, right? So this has a shadow basically. Make the shadow a different color. The shadow is going to be, that different type of yellow, right? 2 different yellows. It's going to look ahead, and while it is equal, we're going to move left, right? Right, we're going to move it. So this is going to keep going until we find an unequal, right? It's going to find it, boom, here, right? And then it's going to stop. Because it stops, we actually have to push it over the edge. Just 1 more, right? Left plus 1. So, this, we've stopped the comparison, but we do want to move it just 1 more, right? And maybe there's a different way to do that. Like maybe I could have, I don't know if Python supports it, but maybe there's a finally I can add here, and then I can do this. But we're not going to take that chance right now, live coding. Let's do the same thing with right. As long as right, I'm going to go back to this diagram. Imagine the right is at this 8. We want to move all the way to say 3, right? So while the right is the same as right minus 1, then the right equals right minus 1, and then the same thing. We want to do 1 over correction, right? So to double check, let's just make sure that all the lefts are being incremented, all the rights are being decremented. Yep. And the 3 sum, if it's too large, we want to move the right 1 to the left. And if it's too small, we want to move the left 1 up. All right. That looks good. And it looks exactly how we wrote our diagram. It looks exactly how we wrote our comments. One thing we always cannot forget, we got to return results, right? At some point we got to return. Aha. We closed the list by accident. Yeah. So when there's too many brackets, it's a little confusing. I think some people would, make these into variables, right? They might do something like ival, lval, rval, and that might make it a little bit easier to read. Depends who you are. Maybe you're not in that way, right? So you might do ival here, lval here, rval here, and then basically everywhere else, right? So ival, shouldn't change anything. Yeah. So a couple mistakes here. Nums has an S. It's a good thing to check. So let me just walk through it before I try it again. I don't want to get into the pattern. When you're interviewing, it's quite possible you don't have a runner. When you're interviewing at a place like Google, which uses Google Docs, you can't run your code. So you got to try it at least once in your head as good practice, right? So start at line 2, 3 sum takes a list of nums. You want to return a list of integers. Results is this array that we started. If there's not enough to do 3sum, let's just return results. Let's get out of here. You sorted by nums, right? So you sort it. You have your P1 loop, which is your first pointer, right? What we wrote right here in gold. And in your P1 loop, you start your P2. Oh, I forgot these others. Okay, so let's write this other code. So if it matches the previous, you can go ahead and skip it, right? So if, what does this mean? So if num's at I, right? And maybe I could have done this up here. Well, that's fine. Let's just do this. So if nums at I equals nums at I minus 1, so it's a match, then we want to just continue. We want to skip it. I guess if this is the first element, it's going to break. So if nums is larger than 0 and this condition, and then, I'm going to zoom in so you know what I'm doing. It's this part right here, right? If it matches the previous, continue. Also, if nums at I, this element is larger than 0, we can also continue because, there's no way we're going to 3sum into a 0. Okay, so, and then we do the red, set up our P2. We do the blue, set up our P3. And then we do some of this green, right? Not some of it, all of it. We do all of this green, which is a 2sum. While left smaller than right, here are the 3 elements. When we do this 3sum, is it equal to 0 or not? If it is equal to 0, we want to add to the results. We want to get left into a valid place. We want to get right into a valid place. Otherwise, we want to move it. And if we move it, we're going to go back into the while loop and we're going to check the 3sum again. And then we, validate it, move it, validate it, move it until we're done. All right. Dang it. Oh, well, that makes sense. Okay, so it's quite possible that we're here. We're out of range, right? And we want to check to make sure that we do not go out of range. So how do we do that? Well, the weird thing is this should not happen. The left should be smaller than the right at all times. If 3sum is 0, yeah, it's super weird. I feel like maybe this while loop statement isn't reached by the time it's here. So I wouldn't think that I need to do this, but if I put this check in front of it, I guess it does do the check. Let's see if it works. Okay, so it does do the check. Okay, so it passes these cases. Passes this case, expected that. Passes this case, expected that. And this expected some numbers. Let's see what's wrong. So this expected -1, -1, 2, and -1, 0, and 1. And it definitely should have had that right here, right? So if I printed this, oops. What's going on there? What was that window? Okay, let's see what these sums are. Okay, so I have -1, 0, and 4, -4. So this is not sorted. Oh my god. Okay. I see what's happening. I actually don't sort it. I have sorted nums here, but I don't have. I'm just going to overwrite it. That's funny. That's a funny bug. That's hilarious. Okay. Let's see what happens if I submit this. So I've printed too much. That's going to be bad for my runtime. You can't just print a ton. Let's hope I get a hot machine and runtime. All right. 81% of users. That's fine. It's not bad. What's important is understanding the time complexity of what we're doing. And this should be n squared. We're doing a for loop here. And then that's going to be times an O of n operation. We have an n log n here as well in the sort. And that's going to be negated by the n squared. All right. So can we do any optimizations? Let's think through this. We have some variables here. We have an appending here. We're doing this while loop. Probably not. Pretty happy with this. This is definitely not an easy problem. I don't know if this got set as easy, but there's just a lot of moving parts, right? The two-sum itself is its own problem, right? The sorted array two-sum is its own problem. And basically this is the two-sum, right? The three-sum is just an extra loop. The three-sum is just an extra loop here where we're getting skipping the block, and we're skipping if it's more than 0. And outside of that, we're also sorting this. So definitely a good problem to practice yourself. Definitely a good problem to practice in 2 stages. You can practice the two-sum first and then add the extra loop. The loop is the easier part. And moving these indices and getting them in the right place, moving the right one, making sure that the left is being subtracted, the left is being added to. That's going to be the hard part. Look forward to seeing your guys' solutions. And, go ahead and leave a comment. If you want a different problem to be done, I'm going to be doing these in order. So follow along for that journey. Thanks.